Welcome to the ninth video of VCAA Math Method 2021 exam paper series. In this video, we will present exam paper 2 section B, question 3, which consists of 6 parts. They relate to superpositioned exponential and logarithmic functions, as well as their properties, including gradients and tangent line equations. It also requires the evaluation of the bounded area between curve, linear line, and the x-axis.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA exam paper series. This is section B of 2021 exam 2 paper. There are total 5 extended response questions in section B. In this video, I will present you the third extended response question here. In this question, function q of x equals logarithm base e of x squared minus 1, or in parentheses minus logarithm base e of 1 minus x, or in parentheses. Part A of this question is to state the maximum domain and range of function q of x. The first requirement of part B of this question is to find the equation of the tangent to the graph of q of x when x equals -2, while the second requirement of part B is to find the equation of the line that is perpendicular to the graph of q of x when x equals -2 and passes through the point -2, 0. Now this question brings in another function p of x, which equals e to the -2x minus 2e to the -x plus 1. Accordingly, part C of this question is to explain why p of x is not a one-to-one function, while part D is to find the gradient of the tangent to the graph of p of x at x equals a. Now the diagram at right shows parts of the graph of p of x and the line y equals x plus 2, as well as the tangent to the graph of p of x at x equals a intersects with an acute angle of theta between them. Based on this, part E of this question is to find values of a for which theta equals 60 degrees. Part F of this question is to find the x coordinates of the point of intersection between the line y equals x plus 2, the graph of p of x, and the x-axis. Now we are going to answer all the parts of question 3 accordingly. Back to part A of this question. Since q of x equals logarithm base e of x squared minus 1, or in parentheses minus logarithm base e of 1 minus x, or in parentheses, the implied domain, or say the maximum domain, must satisfy two inequalities: x squared minus 1 is greater than 0 and 1 minus x is greater than 0. Solving these two inequalities, the domain of q of x we found is less than -1. Since the first requirement of part B is to find the equation of the tangent to the graph of q of x when x equals -2, then we obtain the y coordinate by substituting -2 into the equation. Hence, q of -2 equals logarithm base e of -2, or in parentheses squared minus 1, or in parentheses minus logarithm base e of 1 minus -2, or in parentheses, which equals 0. Then we work out the gradient of q of x at x equals -2. So q prime of x equals 2x over the result of x squared minus 1 plus 1 over the result of 1 minus x. Hence q prime of -2 equals -1. Then we are able to establish a tangent line equation y equals -x minus 2. The second requirement of part B is to find the equation of the line that is perpendicular to the graph of Q of x when x equals -2 and passes through the point -2, 0. So the gradient of the perpendicular line equals negative reciprocal of Q prime of -2, which is 1. Hence, we get the perpendicular line equation, which is y equals x plus 2. Part C of this question is to explain why p of x is not a one-to-one function. According to the rule of p of x, which is e to the -2x minus 2e to the -x plus 1, and it can be written to e to the -x minus 1 or in parentheses squared. Obviously, it has a turning point at x equals 0. So there are horizontal lines that cut the graph of p of x more than once. So it is not a one-to-one function. Part D of this question is to find the gradient of the tangent to the graph of p of x at x equals a. Since p prime of x equals -2e to the -2x plus 2e to the -x, so p prime of a equals -2e to the -2a plus 2e to the -a. Part E of this question is to find the values of a for which the tangent line of p of x and y equals x plus 2 has an angle of 60 degrees. Since the line y equals x plus 2 has an angle of 45 degrees with the x-axis, two angles alpha sub 1 and alpha sub 2 are indicated in the diagram, which can be calculated accordingly. So alpha sub 1 equals 105 degrees and alpha sub 2 equals 165 degrees. Based on the equation, 2e to the -a minus 2e to the -2a equals tangent alpha sub 1 or tangent alpha sub 2 respectively. The values of a can be calculated accordingly in your CAS calculator that are -0.67 and -0.11 accordingly. The final part of this question is to find the x-coordinate of the point of intersection between the line y equals x plus 2 and the graph of p of x first, and then calculate the area bounded by the line y equals x plus 2, the graph of p of x, and the x-axis. In order to find the coordinate of the intersection, we need to solve the equation e to the -2x minus 2e to the -x plus 1 equals x plus 2. With the help of CAS graphic calculator, we obtain the value of x, which equals -0.75. Hence, the bounded area equals the integral from -2 to -0.75 of x plus 2 or in parentheses dx, plus the integral from -0.75 to 0 of e to the -2x minus 2e to the -x plus 1 or in parentheses dx. Again, with the help of CAS graphic calculator, we calculated the area, which is 1.078 units squared. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.